At 9:17 a.m. on April 22, 1942, Lieutenant Commander Edward O'Hare walked through the front doors of the Grumman Aircraft Engineering Corporation factory in Bethpage, New York, carrying information that would change how America fought the Pacific War. O'Hare was 27 years old, had 7 confirmed kills, and wore the Medal of Honor around his neck. The president had pinned it on him the day before. But O'Hare wasn't there for a publicity tour. He was there because American pilots were dying in aircraft that couldn't match the Japanese Zero. The engineer waiting for him was William Schwendler, Grumman's chief designer, 38 years old, with 15 years designing naval aircraft. Schwendler had been working on a replacement for the F4F Wildcat since 1941. The contract had been signed on June 30, 1941, 6 months before Pearl Harbor. The prototype was scheduled to fly in 2 months. But the design wasn't finished, and Schwendler knew it had to be perfect because the current fighter, the Wildcat, was getting pilots killed. The Wildcat was slower than the Zero, 318 mph maximum speed versus 350 for the Zero. The Wildcat couldn't climb as fast. The Wildcat couldn't turn with the Zero, not even close. In a horizontal turning fight, the Zero could complete a full circle in roughly half the time a Wildcat needed. That difference meant death. American doctrine said Wildcat pilots should never turn with a Zero. Never try to outmaneuver them. Use speed, use altitude. Dive in, shoot. Climb out, hit and run. Don't get caught in a turning fight. But the Wildcat wasn't fast enough to reliably execute that doctrine. Zeros could catch Wildcats in a climb. Zeros could follow Wildcats through dives. The performance gap was too narrow. American pilots were forced into turning fights they couldn't win, and they died. The Navy had lost 42 Wildcats in the first 4 months of the war. Most were shot down in situations where better performance would have saved them. The training manual said the problem was pilot error. The tactical officers said these pilots weren't following doctrine. But O'Hare knew better. The problem wasn't the pilots, it was the aircraft. The Wildcat was a good airplane for 1941, but this was 1942, and the Japanese had been flying the Zero in combat since 1940. They'd had 2 years to perfect their tactics. They knew exactly how to exploit the Wildcat's limitations, and American pilots were paying the price. O'Hare had mentioned this to the Bureau of Aeronautics 2 weeks earlier. The Bureau listened because O'Hare had credibility. On February 20th, 1942, he had single-handedly defended the carrier Lexington against 9 Japanese bombers. He shot down 5 of them in under 5 minutes, expending only 60 rounds of .50 caliber ammunition. It was the most spectacular display of aerial gunnery the Navy had ever seen. The Medal of Honor followed, but more importantly, O'Hare had survived 14 combat missions flying the Wildcat. He knew the aircraft inside and out. He knew what worked and what didn't. And he knew what American pilots needed to survive. So the Bureau of Aeronautics sent O'Hare to Grumman with a simple mission: tell the engineers everything. What the Zero could do, what the Wildcat couldn't do, what American pilots needed in the next fighter. Don't hold back, don't sugarcoat it. Lives depended on getting this right. O'Hare spent 4 hours with Schwendler and the Grumman design team. He described Zero tactics in detail: how they baited American pilots into turns, how they used their superior climb rate to maintain altitude advantage, and how they used their exceptional range to extend combat deep into American airspace. He described Wildcat deficiencies: the sluggish controls, the inadequate power, the narrow landing gear that made carrier operations dangerous, the hand-cranked landing gear that left pilots vulnerable during approach, and the poor cockpit visibility that made it hard to spot threats. But O'Hare also described what worked. The Wildcat was tough. It could absorb damage that would destroy a Zero. It had 650 caliber machine guns with good ammunition capacity. It had armor protection for the pilot and self-sealing fuel tanks. American pilots could make mistakes and survive. Japanese pilots couldn't. One good burst from a Wildcat's guns usually meant a dead Zero. The problem was getting into position to fire that burst. That required better performance, more speed, more power, better climb rate, better visibility. Schwendler took notes, lots of notes. He asked specific questions about visibility angles, control responsiveness, engine power delivery, and landing characteristics. He wanted details, numbers, measurements, exact descriptions of combat situations. O'Hare provided everything he could remember. What happened in the next 4 months would determine whether America could win the air war in the Pacific. The first pilot O'Hare knew who died fighting Zeros in a Wildcat was Lieutenant James Gray on February 21, 1942. Gray was part of the Lexington Air Group. Experienced, had flown 30 missions, careful, disciplined, he flew by the book and never took unnecessary risks. On February 21st, Gray's division intercepted 4 Zeros at 8,000 feet near a Japanese airbase. Gray followed doctrine. He dove from altitude, built up speed, took a deflection shot at the trailing Zero, then tried to climb back out, but his Wildcat didn't have enough power. The climb was too slow. One of the Zeros reversed course, dove on Gray, and shot him down. Gray's wingman saw it happen. He said Gray did everything right. The tactic was correct. The execution was flawless. The aircraft just wasn't fast enough. Gray died 3 miles from the Lexington, killed by an enemy he'd already tried to disengage from, following exact Navy doctrine. The official report said pilot error. Gray should have maintained more speed in the climb. He should have anticipated the Zero's maneuver. He should have done something different. But his wingman disagreed. The Wildcat needed more power. Period. Everything else was academic. By April 1942, O'Hare had watched 17 pilots die. Some he knew well. Most he'd only met briefly during ready room briefings or flight deck operations. But he'd flown missions with all of them, had watched them taxi out and take off, and had heard their voices on the radio. Some came back, some didn't. The ones who returned told the same story. The Wildcat was too slow in a climb, too sluggish in a roll, too underpowered for the combat environment they were facing. Most pilots thought that was just how naval fighters handled. Big radial engine, lots of weight. But O'Hare knew that wasn't acceptable. He'd flown against Zeros. He'd survived because he was better than the average pilot and luckier than most. But average pilots couldn't survive in Wildcats, and luck eventually ran out. The Navy needed a fighter that gave average pilots a chance. That meant better performance across the board. O'Hare mentioned this to his squadron commander, Lieutenant Commander John Thatch, one evening after Gray died. Thatch agreed. He'd been working on a defensive tactic called the Thatch Weave that helped Wildcats survive. But it was a workaround, not a solution. The real solution was better aircraft. Thatch asked what could be done about it. O'Hare said nothing from the squadron level. This needed engineering changes that could only come from the manufacturer. It required someone who'd fought Zeros explaining the problem directly to designers. Thatch said the Bureau of Aeronautics was already working on that. They wanted O'Hare to go to Grumman after the Medal of Honor ceremony. It wasn't a request. The problem wasn't that American pilots didn't know what to do. They knew. Every briefing emphasized it. Every training flight drilled it. Never turn with a Zero. Use speed, use altitude. Hit and run. The doctrine was clear. The problem was that combat didn't follow doctrine. William Schwendler had been designing naval aircraft since 1927. He was 41, a graduate of Cornell University, one of the best aircraft engineers in America. He'd worked for Glenn Curtiss before joining Grumman in 1930. He designed the F3F biplane fighter, the F4F Wildcat, and was now leading the team designing the F6F Hellcat. Schwendler knew the Wildcat had problems. Pilots complained about the narrow landing gear, hand crank system, poor cockpit visibility. Those were known issues. What Schwendler needed was combat data. Real information from real fights against real Zeros. The Bureau of Aeronautics provided some reports, but most were second-hand summaries written by intelligence officers who had never flown combat. O'Hare's visit was different. O'Hare had fought Zeros multiple times and survived. He could describe exactly what happened in a dogfight, what worked, what didn't, what pilots needed. On April 22, 1942, O'Hare gave Schwendler that information. The meeting lasted 4 hours. Schwendler took 18 pages of notes. He asked about Zero maneuverability, climb rate, speed at different altitudes, armament, pilot tactics. O'Hare described everything he could remember. The way Zeros attacked from above using superior climb rate, how they baited Wildcats into turns, how they used long range to operate far from bases. Schwendler asked what the Wildcat needed to be competitive. O'Hare said, power. Lots of power. Enough to climb faster than a Zero above 10,000 feet. Enough to outrun a Zero in level flight at all altitudes. The Wildcat's Wright 1820 Cyclone engine produced 200 horsepower. That wasn't enough. The new fighter needed at least 2,000 horsepower, preferably more. Schwendler said the Pratt & Whitney R2800 double wasp engine produced 2,000 horsepower and was already being used in the Vought F4U Corsair. Could Grumman use it in the F6F? O'Hare said yes, absolutely, whatever it took. The entire Pacific Air War depended on having a fighter that could match or exceed zero performance. Everything else was secondary. Schwendler asked about other improvements. O'Hare listed them. Better cockpit visibility. The Wildcat's cockpit sat low. Pilots couldn't see threats approaching from certain angles. The new fighter needed the cockpit mounted higher with all-around visibility. Hydraulic landing gear. Wildcat hand crank system was dangerous on carrier approaches. Pilots needed both hands for flying. Better armor protection. The new fighter needed more armor around the cockpit, oil tank, and fuel tanks. Heavier armament if possible. 650 caliber machine guns were good, but more firepower was better. Maybe 8 guns, maybe 20mm cannons, whatever could fit. Schwendler said all of that was possible. The F6F design was still flexible. Major changes could be incorporated before the first prototype flew.